Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do minimum window substring problem, and if we see some of the companies where I want to get a job, there are companies like Facebook, Amazon, LinkedIn, Microsoft, Lyft, Airbnb, Apple, Adobe, Google, Snapchat, Flipkart, ByteDance, Spotify, TikTok, Bloomberg, Uber, Pinterest, and Goldman Sachs who have already asked this question. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode hard problem, but it is also a very well liked hard problem. Basically, we are given two strings called S and T, and we are given the lengths M and N respectively for each S and T strings. Now we need to return the minimum window substring of given string S such that every character in T, including all the duplicates, that is the key part, is included in the window that we have created from this S. And if there is no such window, then we need to return the empty string. So if we try to understand this with an example, if we take this example, for instance, we are given a string S that looks like this, and we are given a T that looks like this. Now we need to return a substring in this given S such that this A, B, C is present. Now we don't care about the order of this A, B, C. They can be in any order in the new substring that we are trying to create, but we need to return the smallest substring. So if we see one of the substrings that where this A, B, C is present, we can find a substring that looks like this. If we see this particular substring, for an instance, we can see character A, B, and C is being presented. But the thing is, the question is this the minimum window substring? No, this is not the minimum window substring. Why? Because there exists actually a smaller substring where A, B, C is also present, and we can take one more substring that looks like this. So this substring is smaller than this first one, where also A, B, and C is also present, though they are in different order. But this is again not the minimum substring. There is actually a substring which is B, A, and C, where all the values of A, B, C is present. That is continuous substring of this S, and this is the minimum substring where we can find all the characters that are present in T, and we need to return this as an answer. If we see couple of more examples over here, suppose we are given S is equal to A and T also equal to A, we can simply return A as the substring because that is the only substring we can create. Now if we are given S is equal to A and T is equal to double A, which means that there is no way possible for us to create double A from this single A. So in this case we need to return an empty string. So now since we have understood the problem, let's see that what would be the different approaches to solve this problem. So first of all, I'll show you the brute force approach, and if you directly want to check that what is the optimal solution, I have already provided the timestamp, so you can directly jump onto the optimal solution as well. Okay, suppose this is the S and this is the T we are given. We are looking for a substring inside this given S which contains all the letters of this T, and we need to find the minimum length substring for that. Now we can clearly see that there is one substring HBPO which contains all of the elements that are present in T, but the smallest substring we need is actually OBH, which contains all the elements of this T, and that contains the smallest length. The brute force way to solve this problem is that we actually start creating every single possible substring out of this given string S. So we can create substrings like, we will check that okay, this can be a potential answer, we will put it as a potential answer, and we will mark its length. Now eventually we would find a substring that looks like this OBH, that is the correct answer, and then we would return this answer as our solution. So this solution will also guarantee to provide us the right answer, but this right answer is actually very costly. Why very costly? Because we know that it takes big O of n square to actually create all the substrings, and for every single substring we will have to check that whether it contains all the elements of T or not, which means we will have to multiply this by the whatever the length of T is, which is let's say M in this case, which means that we are actually essentially doing big O of n cube work to solve this problem, which is very expensive. Okay, suppose this is the example that we are given, and we are trying to find that what is the minimum substring inside this given S where all the characters of this T is present. So to optimally solve this problem, we are actually going to use sliding window technique with two pointers. So now I have presented the input in a slightly different format, and I have also created that what is the answer we are going to store, because remember in the answer we need to return that what is the minimum substring, and for any minimum substring we need the left pointer and right pointer value, and we also need the length, and we will only choose the minimum length. Now initially we are going to have our left and right both pointers starting at the first position, and now what we will have to check is that we are going to have our right pointer go on the right side until the point where we create a substring where all of these A, B and C are present. The moment we do that, we will note down that what is the answer we have found so far, what is the minimum length, what is the left pointer, what is the right pointer. Once we do that, we will start updating the value of the left pointer to go on the right side until the point when this condition is no longer true and we are not able to make A, B, C in the given left and right string. And again we will update the process on our right portion, and then again we will try to see that whether we can find a better substring or not. So let's see this approach in action. So now to achieve this approach, what we are going to need is that we already have our 2 pointers left and right over here. Now we need to check that at any given substring whether this T is present or not. So if we for every single substring try to check that whether all of the characters of T is present or not, it takes a lot of time. One quick way to do it is that we actually create a hash map for all the characters that are present inside this value number T, and inside the hash map we note that what is the elements and what are the number of occurrences they have. So in this case, for this T hash map, we actually have 3 characters only, and we have 1 occurrence of each of them. So we are going to note it somewhere so it becomes easier for us to record. Now at the same time, for any substring that we create, we will also have to check that whether we have all the satisfied words inside our substring or not. So again we are going to create a hash map for our substring that we are creating as well, and inside the substring hash map we are going to keep on adding the values as we move forward. Now to check hash map every single time is not a very good approach. A better approach in this case could be that we already know that what are the number of unique characters we need inside this hash map. So why don't we just create 2 variables called the number of unique characters. So we just name it as unique that are present inside this T hash map from this given original input, and whatever the substring inside the substring, whatever the unique characters that we have already been able to create. So let's just say that this name is create, and we will keep track of it, right? I'll just show you that how we are doing everything when we keep moving forward on the with our example. So initially left and R both are at this position, and currently we will note that okay, A is not present inside our given substring, so we will add an entry for A, and so far we have received 1 occurrence so far, right? Now originally this T hash map had 3 unique characters, so we are going to note that there are 3 unique characters that we have to find in any given substring. And so far, because this current right position is at A, we have already found one of the characters of the required occurrence, right? So we will note down that okay, we have already received one of the characters. Now our right pointer is going to the next element because we haven't satisfied our full condition. So now we identify that okay, this value is actually B, so we are going to add an entry over here inside our substring hash map, and we are going to say that we have found 1 occurrence of B, and this 1 occurrence of B is already also required inside this given hash map as well. So we can note down that okay, out of this 3 required, we have actually found 2 unique characters that are needed, right? We are good so far. Now next thing we are going to do is that again over here we are going to update the value for right pointer. We encounter that this value is actually A, so we are going to add one more entry to our required pointer. So over here we have found 2 occurrences of A, but that does not solve our problem because our unique and create are still not same. So now we are going to update the value of our R again. So now again R is at this position X is not present over here, so we will add an entry for X is equal to 1, but this X is actually not present in this T hash map, so we can't do anything about it. Now again we will going to update our value of R. So R is at this position. Now because R is at this position, remember that this is the value of C is actually 1. C was the remaining value inside this T hash map. Now we have 3 unique characters that were needed, and we have already created 3 unique characters inside this given hash map. So now we are going to treat this substring as our answer, because remember we needed to have the values A, B, C, and A, B, C are actually present over here. This is A, this is B, and this is C inside this given left to right substring. So we have found one potential answer. So first of all we are going to check that okay, what is the length of this one. So length in this case is 0, 1, 2, 3, 4. So length is actually 5, and the left pointer is at 0 position and right pointer is at 4 position, and we are able to add this entry to our answer because we don't have anything before. So that's why we were able to add an entry to our answer. Now we are going to update our left pointer until to the point when this condition is no longer true. So now because previous value of left pointer was over here, and now we jump to this place. So now left pointer is at here, but the moment we updated the left pointer, we will also have to remove the value of our reduce the value inside our substring hash map. So now there is only one occurrence of a. So far this condition is already true because both this 3 and 3 is matching, right? Now again we are going to update the value of our left pointer to one more character. So now left pointer is over here. Now this b is actually 0, so we are going to remove the entry for b. Now because we remove the entry for b, we have only created two elements that are needed inside this substring from this position 2 to position 4, which is a and c. We don't have b entry, which means now we will have to update the value for right pointer until we find the b. Now lucky for us, b is actually very next to this right pointer. So now right pointer is over here and b is actually over here. So b is 1, we will add an entry over here, and now we have already created all of 3 elements needed rather than 2, and we are done with this case, right? So which means we can say that this new substring is also a potential answer. And let's see that whether this substring is actually better than our previous answer or no. How can we determine that? Remember, the aim of this question is to find the minimum length of the substring. So we are going to compare the length of this one. So length of this one is actually 4, and the current answer we had was actually of length 5, which means it is in our interest to update the length over here. And the moment we update the length, we will also have to update the left and right pointer over here. So left pointer currently is at 2 position and right pointer is at currently at 5 position. Now we have found a potentially better answer. Now again we are going to update our left value because we have already found the answer. So now left comes over here, which means we will have to reduce this value of a. So again we are going to reduce the value of a. So a is now 0, so there are no occurrences of a. Because there are no occurrences of a in this new substring, we have only created 2 elements out of this 3 unique characters that we are needed, and which we can see in this particular substring from this position number 3 to position number 5, that we only have c and b, we don't have a. Now we are going to update the value for right pointer. Now again when we update the value for right pointer, lucky for us, we are actually able to find one a. So we will add an entry inside our substring hash set that okay, now we have found one character. Now we can say that we have created all 3 characters that were needed. Now this is also potentially a new substring, and can this be a better answer? So we'll check. Okay, in our length we already have an answer of 4 inside our answer array that we have stored, and this is also an size of 4. So which means that there is no point in updating our answer. We already have the same answer with the same length. So we are going to go to the next case. So now again we increase our value of left. So now left is again at this position. So we will have to ignore this x because we already got rid of it, which means that we have already traveled all the values so far. And now we are at CBA. Now CBA, again this is all of these 3 elements that were needed, and we already have that, which means that this is also potentially a better substring that we have found, and the length of this is actually 3. So because the length of this is 3, this can be a better answer. So we will note it down. So this is 3. Now left pointer value is 4 and right pointer value is 6. So we have found a potentially better answer. Since we have already found an answer and we know that this is a valid substring, now we will have to update the value for left pointer. So once we update the value for left pointer, we are actually going to ignore the c. So now we get rid of the c inside our hash set. Now we also get rid of this l, and now we have taken care of all of these elements so far. Now that we only have ba, which means we only have 2 elements out of 3 that we needed. Now again we will have to update the value for right pointer. So again we update the value of our right pointer over here. We find that okay, this value is actually c occurrence is 1, which means we have created this element actually 3. All of this is successful. Now we check that okay, length of this is actually 3. We already have an answer of length 3, which means there is no point in updating that. Now we will update the value for left pointer. We will ignore this b. So if we ignore this b, now we only have 2 elements out of 3 needed. So because we have 2 needed, we will have to update the right pointer. So now when we update the right pointer, we are actually going to be at the end of our string, and because we are at the end of our string, we can actually break out of the loop. And the moment we break out of the loop, which means that whatever the value we have stored inside the answer, we have the left pointer, we have the right pointer. So all we need to do is we need to return the substring. So if we return the substring in this case, we will have to return return the substring that looks like this. So the answer in this case is actually going to be CBA, which is the minimum substring that we can achieve, that contains all the elements of the T that are present over here. And remember, over here we are using hash map and substring hash map to find the answer. In order to make our lives easier, we have created two elements to know that what are the unique characters that we need to compare. In case, because this was a string and we know that there can be only a finite number of unique characters, which is 26, we were able to use this technique. But your interviewer is for sure going to ask you that rather than having a string and having finite number of unique characters, you are actually going to have millions of hash code characters or something like that. In that case, you will not use this technique, and you will actually just simply have to check over the hash map for every single substring that you are going to make. So this is one of the approach where we can find the optimal solution, and it works as expected. If we see the time complexity is actually going to be O of whatever the length of string is plus whatever the length of T is. And why we are able to achieve this time and space complexity? Because we are using this technique, so that makes our lives a little bit easier. If we see the space complexity is also going to be actually O of the whatever the size of S is plus whatever the size of T is, and this also works because we are creating two additional hash maps and we need to take care of that space into account. But overall, this is still much bigger improvement in compared to our brute force approach. Now there is one more approach to solve this problem, that whatever the input that is already given, first of all, whatever we create the same hash map we create for this element number T, which means that we actually use the same hash map that I have drawn over here to compare all the values of T. But for this value number S, actually remember that we only need to find the substring of characters that are present in T. But so if that is the requirement, why do we even bother checking this element X or any other element that is not one of these values? So a better way to solve this problem is to create another hash map where we ignore this X and we only keep character inside this given string that are also present in the inside this given T. And in this particular hash map, we also identify that what is the index value for every single element. So in this case, we will determine that okay, this A is actually present at 0th position, then again we have a B that is present at first position, again we will mention that there is an A that is present at second position, and so on and so forth, and then it will make our lives a little bit easier and we can solve this problem. But I don't think in an interview, even if you show this approach, they are going to completely reject your suggestion. So that is why I am choosing this one. Let me know in the comments if you want me to solve the other approach as well, where we are only going to use the unique characters that are also present inside this given T. So first of all, we are going to check some edge cases if the given string is empty or if the length of the given T is actually greater than length of S. If that is the case, we can simply return as empty string. Now if that is not the case, we will create a hash map to store the value of this T string inside the hash map for all of its characters. We are going to name it as map T. Now we are going to run a for loop across this given string T, and we are going to add all the entries to our map T. After the loop ends, we are going to create a variable called required that gives us the number of unique characters that are present inside our given map T hash map. Now we are going to initialize bunch of different variables to keep track of different things. So first of all, we are going to initialize variable called left and right to keep track of our 2 pointers. Once that is done, we will create a variable called create that defines that what are the number of variables that we have created so far that are also present inside the given T. And we are going to initialize an integer array to store the value of answer, and we are going to initialize the first value as -1 inside the answer, where we are going to keep track of the length of current substring, and we are going to have 2 more entries to store the value of left and right pointer, and we are going to initialize those values as 0 as well. We will also create a hash map to keep track of all the values that we have found so far inside the current substring. And now we are going to run our while loop across the string S, and we are going to run it until the right pointer reaches to the end of the string. So inside our loop, first of all, we are going to add an entry to our hash map for any particular given substring. After adding a value to our substring, now we will check that whether all the elements we have added in the substring is that element also present inside our map t as well. If that is the case, we can increment the value of number of characters that we have created in our substring that are also required inside our map t as well. So if this condition is true, we will update the value of our create variable. Now after updating that, we will also have to check that whether the current substring, if that is valid or not. And by valid I mean that whether the required and create has the same value. If that is the case, we will have to update the left pointer and we will have to shrink our size. Also we will have to add entries to our answer array as well. So we are going to run another while loop, that while left is less than or equal to right, and the required is and created are same. We are going to check that whether we need to update our answer or not, and we are also going to update the value of the character c variable to help us in doing a lot of other things, and we are going to assign it the value of the current left pointer. Now we check if we need to update the answer. After updating the answer value, we will also have to remove the entry from our substring map because we are updating the left pointer. And after removing the entry, again we will have to check that whether the value of our entry that we just removed, did it caused us to reduce our create variable, which means that have we removed any entry which was also present inside our map t hash map as well, which was required for us. If that is the case, we will have to reduce the value of our create variable, and it could make us break out of this loop as well. In any case, we will have to update the left pointer, so we'll update the value of left pointer. And after that is done, we are done with the inner loop. In the outer loop, we will have to update the value of right pointer, and that's it. So basically after this loop ends, essentially we would have taken care of all the scenarios that are needed for this loop, and now we will work on returning the answer. So for the answer, we will have to check that if the value of answer of 0 is equal to -1, which means that we are not able to find any value that were suitable to create as a valid substring. If that is the case, we will return an empty string. If that is not the case, we will return the value inside our answer array for this left and right pointer value, which means answer of 1 and answer of 2. But we will have to do right plus 1. Why plus 1? Because the indexing works from 0 to r, so that's why we will have to add one more entry to our right. Let me try to run this code. Oh, we made some mistake in generating the answer. Okay, seems like our code is working. Let's try to submit this code. And our code runs as expected, and I would be posting this solution in the comments so you can check it out from there. Thank you.